Jupiter is nothing like you were taught. Jupiter looks familiar. A massive planet wrapped in colorful clouds. A giant ball of gas floating quietly in space. That's the version most of us learned in school. And it's almost entirely wrong. Jupiter isn't just misunderstood. It's one of the most misclassified objects in our entire solar system. Beneath those beautiful swirling bands lies something far stranger than a gas giant. Jupiter is not a hollow puff of vapor. It is a crushing, violent, liquid world hiding secrets we've only begun to uncover in the last few decades. For centuries, humans could only observe Jupiter from afar. Through early telescopes, it appeared smooth, distant, and unknowable. Even when spacecraft finally arrived, they didn't immediately give us answers. They only deepened the mystery. The first close-up image of Jupiter was captured in 1974 by NASA's Pioneer 11. For the first time, humanity saw the planet not as a point of light, but as a world. 5 years later, Voyager 1 followed, sending back moving images as it raced past the giant. These visuals were stunning, but scientifically frustrating. They showed motion, storms, and color, yet revealed almost nothing about what Jupiter actually is. The biggest problem was scale. Jupiter is so enormous that the human brain struggles to process it. Its mass outweighs every other planet in the solar system combined. You could fit over 1,000 Earths inside it and still have room left over. If Earth was shrunk down to the size of a grape, Jupiter would loom beside it like a full-size basketball. With that much mass, Jupiter's gravity dominates its surroundings, and likely shaped the entire solar system during its formation. For decades, scientists believed they understood how Jupiter formed. The leading theory suggested that a dense, rocky core formed first, then grew large enough to pull in vast amounts of gas from the early solar nebula. Over time, that process would create a massive planet wrapped in thick hydrogen and helium clouds. It was a clean, logical explanation. There was also a more radical idea, that Jupiter may have formed more like a failed star, collapsing directly from a massive cloud of gas before being captured by the sun's gravity. If that were true, Jupiter wouldn't even have a solid core at all. For years, both theories remained untested. We simply didn't have a way to see inside the planet. Then, in 1995, something extraordinary happened. A comet, torn apart by Jupiter's immense gravity, slammed into the planet at speeds exceeding 200,000 kilometers per hour. This wasn't a single impact, but more than 20 separate collisions over several days. Each strike released energy on a scale humanity had never witnessed before, explosions so powerful they rivaled hundreds of millions of nuclear bombs combined. By sheer coincidence, NASA had two priceless tools in the right place at the right time. The Hubble Space Telescope watched the aftermath from Earth orbit. Meanwhile, a spacecraft named Galileo was approaching Jupiter itself, perfectly positioned to observe the chaos up close. What followed was unlike anything scientists had ever seen. The impacts punched dark scars into Jupiter's clouds and blasted material thousands of kilometers into space. For the first time, fragments from deep within Jupiter were exposed, and Galileo flew straight through them. And what it detected would force scientists to rethink everything they thought they knew. Because hidden within those clouds was water. A lot of it. And that discovery would trigger a new mission, one designed not just to observe Jupiter, but to peel it apart layer by layer. Because if water existed there, what else was hiding beneath the clouds? A world of endless storms. If you could hover above Jupiter's cloud tops, the first thing you'd notice isn't the beauty, it's the violence. This planet never rests. Jupiter's upper atmosphere is a chaotic battlefield of motion, where gases race around the planet at speeds faster than Earth's strongest hurricanes. These clouds aren't thin wisps either. They're stacked in thick, towering layers, twisting into endless bands that wrap all the way around the planet like giant conveyor belts. Up here, temperatures plunge below -100 degrees Celsius. Water doesn't behave the way it does on Earth. Instead of falling as gentle rain, it forms ice crystals mixed with ammonia, a chemical that acts like antifreeze. This strange combination allows liquid water to exist in conditions that should freeze it solid. As these icy particles collide, Jupiter's clouds become electrically charged. The result is lightning on a scale that makes Earth storms look insignificant. Bolts of electricity flash across the planet, some stretching hundreds of kilometers through the atmosphere. These storms don't last for hours or days. They can rage for years. But the most famous storm of all is impossible to miss. The Great Red Spot. It's larger than Earth, wide enough to swallow our planet whole. This colossal storm has been raging for at least 350 years, possibly much longer. No one alive today has seen a time when it wasn't there. And it isn't just wide. It's deep. The Great Red Spot extends hundreds of kilometers below Jupiter's visible cloud layer, plunging far deeper than any storm on Earth. It rises higher than surrounding clouds, absorbing more ultraviolet radiation from the sun. That energy triggers chemical reactions that give the storm its deep, rust-red color. Imagine a hurricane taller than Mount Everest, deeper than Earth's deepest oceans, and powerful enough to last for centuries, and you still wouldn't fully capture its scale. Yet for all their drama, Jupiter's clouds are just a thin skin. On average, this entire chaotic weather system is only about 50 kilometers deep. Beneath it lies something far more extreme. As you descend into Jupiter's atmosphere, pressure increases rapidly. Gravity squeezes everything tighter and tighter. Gases are compressed, and compression generates heat. The deeper you go, the hotter it becomes, not because of the sun, but because of Jupiter's own immense weight. Eventually, the atmosphere becomes so dense that it stops behaving like a gas at all. Hydrogen, the lightest element in the universe, begins to change. Around 1,000 kilometers below the cloud tops, hydrogen gas is crushed into a liquid state. There is no solid surface here, no land, no rock, just an endless, churning ocean of liquid hydrogen, the largest ocean in the entire solar system. This ocean is nothing like water. On Earth, hydrogen becomes liquid only when it's incredibly cold. But inside Jupiter, the opposite happens. Pressure raises hydrogen's boiling point so high that it remains liquid even at temperatures above 1,000 degrees Celsius. This liquid ocean is around 20,000 kilometers deep, nearly 2,000 times deeper than Earth's oceans. And as we sink even farther, gravity pushes matter into a state so strange that it barely exists anywhere else in nature. Because at the bottom of this ocean, hydrogen stops behaving like a gas or a liquid and becomes something entirely different. The metallic heart of a giant. As we descend deeper into Jupiter, familiar physics begins to break down. The liquid hydrogen ocean stretches for tens of thousands of kilometers, growing hotter and denser with every passing layer. Pressure here is beyond anything we can recreate on Earth, millions of times greater than atmospheric pressure at sea level. Under these conditions, matter stops behaving the way textbooks say it should. And then, something extraordinary happens. Hydrogen changes its identity. At temperatures approaching 10,000 degrees Celsius and under unimaginable pressure, hydrogen atoms are forced so close together that their electrons break free. Instead of orbiting individual atoms, these electrons begin to flow through the liquid itself. The result is metallic hydrogen. This isn't metal in the way we think of iron or steel. It doesn't form solid structures or sharp edges. It remains a liquid, more like molten mercury, but with one crucial difference. It conducts electricity. Vast oceans of electrically conductive metallic hydrogen flow beneath Jupiter's surface, forming the largest natural electrical system in the solar system. As this liquid metal churns and circulates, it generates an enormous magnetic field, the strongest of any planet orbiting the Sun. Jupiter's magnetic field is so powerful that it stretches millions of kilometers into space, creating a protective bubble that dwarfs the Sun itself. If you could see it with your eyes, it would appear larger than the full moon in Earth's sky. This invisible force traps deadly radiation, sculpts glowing auroras at Jupiter's poles, and violently interacts with its moons. Any spacecraft entering this region is bombarded with radiation strong enough to damage electronics and threaten human life. And all of it is powered by a sea of liquid metal deep inside the planet. This metallic hydrogen layer alone is roughly 40,000 kilometers thick, making up the majority of Jupiter's interior. For a long time, Scientists believe that beneath this metallic ocean lay a simple, solid core, a dense ball of rock and iron, roughly the size of Earth. That assumption made sense. After all, most planets form around solid cores. Jupiter should be no different. But when NASA's Juno spacecraft arrived in 2016, it brought instruments sensitive enough to measure Jupiter's gravity in exquisite detail. By tracking tiny variations in the spacecraft's motion, scientists could map how mass is distributed inside the planet. And what they discovered was deeply unsettling. Jupiter does not have a clear, solid core. Instead of a compact center, the data revealed something far messier, a fuzzy core. Rather than a sharp boundary between rock and metallic hydrogen, the two appear to blend together. Heavy elements are spread out, diluted, and mixed into the surrounding liquid metal. This fuzzy core spans nearly half of Jupiter's radius. It's less like a solid object and more like a dense, chaotic soup of rock, metal, and hydrogen, stirred endlessly by the planet's immense gravity. No one expected this. Scientists scrambled for explanations. One leading idea suggests that early in the solar system's history, Jupiter may have suffered a catastrophic collision. A rocky planet, perhaps 10 times the mass of Earth, could have slammed into Jupiter at high speed. The energy of that impact would have shattered and scattered the core, mixing it into the surrounding layers. It's a dramatic theory, but when researchers tried to simulate such collisions, they ran into a problem. In nearly every scenario, the fuzzy core eventually settled back into a solid one over time. Jupiter's didn't, which means either our simulations are missing something, or Jupiter's formation was far stranger than we currently understand. Despite decades of observation and multiple missions, we still don't know how a planet like this comes into existence. And that uncertainty is what makes Jupiter so fascinating. It looks familiar from a distance, but inside, it defies everything we thought we knew about planets. The planet that shaped everything. Jupiter isn't just the largest planet in the solar system. It's the most influential. Long before Earth formed oceans or life took its first breath, Jupiter was already there, a gravitational giant reshaping the destiny of everything around it. Its immense mass didn't simply occupy space. It actively sculpted the solar system during its earliest, most chaotic years. In the newborn system, planets didn't glide gently into place. They collided, migrated, and were flung violently through space. Jupiter, with its overwhelming gravity, acted like both a protector and a destroyer. One moment, it pulled asteroids and comets toward itself, absorbing impacts that might otherwise have struck the inner planets. The next, it hurled debris outward, ejecting objects entirely from the solar system or redirecting them onto new, unpredictable paths. Without Jupiter, Earth's history might have looked very different. Many scientists believe that Jupiter's presence reduced the number of catastrophic impacts Earth experienced during its early formation. By acting as a gravitational shield, it may have prevented constant planet-sterilizing collisions, giving life a chance to gain a foothold. But Jupiter is no gentle guardian. Its gravity also destabilized entire regions of space. It prevented planets from forming between Mars and Jupiter, leaving behind the asteroid belt, a graveyard of worlds that never quite came together. Some of those fragments still cross Earth's orbit today, reminders that Jupiter's influence is both protective and dangerous. Jupiter even reshaped itself. Evidence suggests that the planet may not have formed where it currently sits. Early in its life, Jupiter likely migrated inward toward the Sun before reversing course and moving back outward again. This planetary dance would have scattered material across the solar system, mixing rocky and icy matter and influencing the composition of planets like Earth and Mars. This migration could explain Jupiter's strange internal structure, its fuzzy core, its diluted heavy elements, and its extreme magnetic field. In other words, Jupiter's current form may be the scarred result of a violent past. Despite all we've learned, Jupiter remains deeply mysterious. We still don't fully understand how metallic hydrogen behaves under such extreme conditions. We don't know why Jupiter's core never resolidified. And we don't yet know whether Jupiter is unique, or if similar worlds are common throughout the galaxy. But what we do know is this: Jupiter is not a simple gas giant. It is a layered, liquid, electrically charged world, a planet that blurs the line between planet and star, a place where storms outlive civilizations, where oceans conduct electricity, and where gravity shapes the fate of worlds millions of kilometers away. Every new mission reveals answers and raises even more questions. Future probes may one day dive deeper, measure more precisely, and finally uncover how Jupiter was born. Until then, it remains a colossal enigma hanging in the night sky, silently influencing everything in its reach. When you look at Jupiter through a telescope, you're not just seeing a distant planet. You're looking at the architect of our solar system. White right pointing backhand index, but Jupiter isn't alone. Even stranger worlds exist, planets made of diamond, worlds raining glass, and giants hotter than stars themselves. The universe is far more alien than we ever imagined.